I'm Ignacio. I work for Canonical. I'm a solutions architect, and I'm going to deploy an OpenStack with LXD containers in the short time we have for this demo. So I'm going to rush to deploy it right away. This is Juju. This is our modeling tool. It's used to model not only OpenStack, but any 5G, MySQL, WordPress, any software that you can think of. It's been charmed, and we have bundles for it. It's a whole ecosystem of applications. So if you go to the Juju store, I'll look for OpenStack. You will see several bundles. For telemetry base, I'm going to deploy the simplest of all here with LXD. I'm going to add it to my canvas. And Juju, as a modeling tool, is able to deploy to Amazon, to Azure, to Joyent, or to your own metal. In this case, we brought our small cluster. This is a box full of 11 nodes, small Nuke nodes with it's i7 cores. So this is the OpenStack. We commit changes, we deploy. I need to start to deploy right away on this box. If we do a Juju status, you will see that that OpenStack has just started deploying. It's pending. It will take about 25 minutes, so we have just the time to do it. Okay. And I'm going to talk, while it's doing it, about MAS. MAS is what we have now in this box. It's MAS Metal as a Service. Think of it of metal in the cloud, so you can grab resources or whatever node you need. It will deploy the operating system, deploy whatever software you have there. And MAS, as you can see here, you can the road was bumpy over here, so one of the cables just went out. I just marked it as broken. Some of them, these are virtual machines which were on that node, and it's just taking the other nodes, the ones that are free. And as you can see, it is deploying there. It has very interesting features like tags. With tags, you will be able to tag any node. Let's say that you have a node with a 10 gigabyte NIC, and the rest of them are 1 gigabit. So you just tag that machine as 10 gigabit, and in the charms, in the software you saw before with Juju, you can say, okay, the neutron gateway must go to the machine with this tag. So it's a way of customizing if you want your deployment. We generally, our favorite architecture is hyperconverged architecture, very similar to our previous presentation. What we do is, instead of making, for example, 3 nodes for compute, 4 nodes for storage, then the rest of the services of OpenStack in 1 or 2 nodes, we prefer to spread them all across the nodes. And that way, we're able to hyperscale, to go to tens of thousands of nodes. And not only that, but with Juju, you will be able to upgrade almost with a single click any service of OpenStack. You will be able to go from Kilo to Mitaka, from Mitaka to the latest released Otaka. And yes, that's the magic of Juju. Juju not only acts on bare metal servers, on the virtual infrastructure, but can also take orders from the orchestrators. So let's say that's what we're doing, for example, in Telefonica right now. We're talking to their OpenMano orchestrator, so it's able to launch machines, delete machines. Think of the lifecycle management program. For example, in the night you might need more nodes for compute, during the day less. So Juju will not only talk to the infrastructure, but also to the orchestrators, and you will be able to manage your whole infrastructure in a seamless way. Okay?
What kind of orchestrator do you
So, sorry?
What is the orchestrator?
In this case, we're doing it with Telefonica For OSM, it's open source Mano thing, and that's the orchestrators we're using. But as I'm saying, it has an API, so if you have your own orchestrator, you will be able to talk to Juju. Okay, so let's check how is this going. You can see here, as promised, it's been delivered with containers. These are LXD containers. Just as a reminder, or for anybody who doesn't know, containers like virtual machines, you can launch instances with them, but instead of getting the whole operating system and launching it, this is part of virtualization, which means that you have your own operating system. Creating an instance is as easy as creating a user, which takes milliseconds, and assigning resources to it: memory, hard drive, network, and with containers you will save a lot of machine resources, and you will be able to put many more virtual machines, instances, as well as duplicates of your services, of your OpenStack service, on less nodes, and that's the beauty. So. Yep.
Are container instances? Are the container instances?
No. In this case, what we're doing is the containers are the services of OpenStack. We're deploying it, but we also do. We can also launch the instances in LXD in containers. Okay.
I'm sorry for a stupid question.
No, please. This is interactive.
Compared to Docker instances, or?
Docker is different. Docker, as you know, 90% of the Docker the developers, they use Ubuntu, and they even use containers behind those Docker. But Docker is application containerization, and it can present you more problems, because when you containerize an application, it doesn't inherit the network, for example, from the machine. You have to set it up, and there are more uses of compatibility than with containers, pure containers. Because with the containers, basically you inherit the whole operating system, and there's not an advantage of speed when you do it with Dockers instead of containers. So, but in short, you can use containers. You can use Docker with containers, but in my own view, containers are much more powerful because they have the whole operating system with them. So you will have many less problems than, for example, networking problems than when you use pure Dockers. Okay. Just.
So I have a question. So this deployment you show us, when you deploy OpenStack.
Yes.
And this OpenStack is delivered in containers, or not?
This OpenStack is delivered in containers.
In the networking world, so
Yes, it is. As you can see here, those services there, Nova Controller, Neutron, Ceph, they're all being built inside these containers. We're right now using 4 machines, and we have 3 containers per machine. Okay. So.
Juju is used to deploy applications in containers, or?
It can deploy applications in containers. It can deploy applications on virtual machines. It can deploy applications on pure metal as a whole server. So in this case, we're doing it with LXD containers. By the way, LXD is the daemon of the containers. The containers themselves are LXC. So you can use both words, okay? So any more questions? If you have questions, I'm more than happy to answer, okay? Now, this is a model. You can see it as a canvas, but you can have several models. I mean, you can switch to another model here, for example, default. And then, and you can start a whole new model here. Let's say you want to have something completely different, Kubernetes, for example, and you will be able to deploy again on different nodes that are free for you. You will be able to deploy whatever software bundle you need. Okay. And I'm going to show you some, let's say, Plum Grid. I'm going to talk to you about big software now. OpenStack is just the beginning. I mean, and it's quite complex, as you all know. It takes some time to deploy it. It's trim bundle. Wait, hold on. This is the web page you can go to try Juju for free by yourself. Even Mass is absolutely free up to 10 nodes, 10 physical nodes. So feel free to go and try it at home if you want. So let's see. Plum Grid. That's another model. You can see it properly. The screen is a bit small. Okay, so you can see here we have an OpenStack with some extra features. And this is only the beginning. As I was saying, the years to come, you will see more and more complex software, and it's going to be almost impossible for any medium-sized enterprise, even large enterprises, to have 20 engineers just expertising in everything. And with Juju, we have bundles. So it would be a matter of a click to deploy it the same way that you see in OpenStack. And that's the true power of Juju. I mean, making dealing with big software that it's becoming almost impossible to operate. So let's see how controller. That's our OpenStack there. By the way, we use Ceph, but you can use Swift as well, pure object storage, or our favorite solution is Ceph, since it distributes storage across all nodes, and it's very in line of what I told you about hyperconverged architecture. It's the way to scale to thousands of nodes. Sometimes you won't need it. Some telcos, for example, they do like to have separate nodes for Neutron, for example. But in the most general cases, the hyperconverged architecture is the solution.
If one container goes down?
If one container goes down, it won't do anything. Nothing will happen. The thing will start working, even not only a container, but even a physical node with a lot of containers there. You plug out the cable, the power cable, and we deploy it in HA. So you will have several horizons, several Cephs. Everything is replicated across the physical nodes. As you can see, a lot of services have started. Once we get everything started, we will log into Horizon, and you will see that the deployment has actually worked. Okay? So feel free. We have free time. Feel free to ask whatever you want, because this is the power of Juju. I mean, even if in a half-hour talk, it will be deployed. I only had to click once. This is what everybody wants. You know, nobody wants to be dealing with VI and scripts and having to say, okay, this service has to relate to this other. So I will show you with a very simple example as well.
Can you maybe show, because the work is of course in creating the bundles, configuring that, so it's the kind of, you pull up the recipe and then execute it with
Yes,
the recipe.
I mean, our philosophy is do not repeat something that someone has done before.
Yes.
That's the principle of any engineer.
Can
So,
you show a bundle? Can we zoom in on
yeah, well, you mean the bundles in the store? Or you mean the actual text file where the bundle is defined?
yeah, somewhere this is configured.
YAML file is it?
Yeah. No. The YAML file, it can be, you press here and you export it and you will see it. Okay. Bundle YAML. Okay. That's very simple, YAML file.
Deploy.
Export. Oh, sorry, that was the demo default video. There you have it. Okay, that would be an example of the bundle, and yeah, everything is defined there. And as I said, also in the YAML file, there's another YAML file where you defined where is it going to be deployed to. Okay, and in future versions, we will have. Sorry. In future versions, you will be able not only to deploy with the canvas to the physical, to a particular data center, but you will be able to deploy different charms to different data centers, and they will still be connected. But this is work for short distance in the future. Okay, so let's see. Oh, I'm going to show you basically the very basics of Juju. I'm going to build a very simple example, so that if anybody in the audience didn't get the notion of what Juju is about, you will see it clearly. Let's say we want to build a WordPress server. We click on WordPress, we add to Canvas. Here we have it, beautiful. Now, WordPress works with a database. So we look for the database. We're going to make a bundle, okay? So you'll see it. Sorry, MySQL. There we are. So instead of going to WordPress and saying, okay, my database is here with this IP, with this authorization, there's work to do there. Instead of doing that, you just click on one of these and relate it to the other. Now those two services are related, and you are ready to start using WordPress. Let's say that it's everybody's using your server. It's the CPU is getting hot. You need more servers. So what do? You put an HA proxy. A load balancer, basically. All that I'm doing graphically, of course, it can be done via command line, okay? So now we have it with an HA proxy. And that's it. That's the magic of Juju. Now you can deploy it. You can deploy it one for each machine. You can deploy them all on one machine. You have that flexibility. That would be the most simple case. As I said, you can get as complicated as you want. There's only one service left to deploy, I think. No, it's Keystone and Ceph. You see, all the containers have started. The container can have started, but the services in it might be already working and trying to communicate to each other. So in about 5 minutes, it will be done.
Maybe a last question.
Yeah, to ask.
Are you actually now deploying this OpenStack configuration on OpenStack with Juju?
Yes, I'm deploying the whole OpenStack.
Creating an OpenStack environment on a running OpenStack.
Yeah, you will see it. All the servers, all the servers in this box, which is just for demonstration, were powered off, and Juju, in combination with MAS, Metal as a Service, was able to power them on, to deploy the operating system, deploy the services, and start making the relations. That's what it's finishing doing now, the relations between the services. So it's how long did it take for you to build an OpenStack? I mean, at least weeks or even months, right? so I find,
A little bit confused.
yeah, it's quite impressive to see.
It's so hard, but it's
And this is not like easy solutions like DevStack or PassStack. I mean, this is big software, as I said. We have a collection of software from radio access, 5G, to OpenStack. I invite you to go to the Juju Charm shop and check the software and the bundles we have there, and you will see how easy it is to deploy. Now, don't worry about that blocked. It's something. A service until it gets all the relations. It gets blocked. It will get unblocked very soon. Yeah.
There are more questions.
Sorry. More questions, please.
What does it take to get a machine into MAS? You got a Metal as a Service. I got a machine standing. What does it take to get a machine into MAS? What do you have to do?
Oh yes, yeah, good question. Let's say in OpenStack you used to have 2 networks, right? We're going to put a MAS. I hope everybody can see. Let's put a MAS Metal as a Service in one of the machines here. So any other machine that you start, let's call this the deployment network. So any machine that you put in here, it will be automatically detected by MAS. It will detect its RAM, its CPU, its hard drives, the networks it has been connected to, because this is the deployment network. But let's take another color. You can have an external network for the floating IPs. You can have another network for, let's say this, another network for APIs, for example, to show the APIs of your different services. But answering to your question, any machine that you put here, in MAS, you just commission the machine. There's an option. Once you power it on, the machine, you plug it to the net. You power it on, and MAS will show it here. It will give it an arbitrary name, like Lonely Wolf. And then you change that name for your convenience. And then you commission that machine. And when you commission that machine, it's a single click here.
So is that PXA?
So, yeah, well, it uses PXE to boot, and also the IPMI protocol. to get all the information from the BIOS of the machines. So yeah, it's pretty easy. So if you need more power, more compute power, you just call Dell, for example. Okay, send me 10 servers with this BIOS configured to PXE boot and the IPMI protocol on, and you take that from the box, you connect it to the network, to this deployment network, and MAS will detect it and will start using it right away with Juju.
Exactly. Is it ready because the time's up?
Yeah, the time. Yeah. Let's see. I mean, it takes 25 minutes, so it's a pity. It would be a matter of a few minutes, but let's say Horizon. Dashboard. We went into the dashboard, we exposed the service, we get the IP address, and if we open a new window, Horizon. They will.
Which I can set details. And have on my config. What is your favorite?
As you see, everything. It's just a matter of minutes. If by any chance I don't have the 1 or 2 minutes left, just feel free to go to our booth and we will deploy it again in 20 minutes in front of you. Okay, so let's hope.